Okay, class, in this video, I'm going to try to tie everything together. So we have three sets of DNS servers. External DNS servers that are resolving all the computers in the DMZ to public IPs. We have internal DNS servers that are resolving all of our computers in our network to private IPs. And lastly, we have servers on the internet resolving public names like google.com, yahoo.com, things like that. Okay, so guys, I updated our network map. I've included our private network IP, the IPs for those two DNS servers, and I've updated our public IP addresses. Now I'm going to go to DC DNS1. So if we look at the network adapter on this machine, we look at the client DNS settings, I can see that the DNS client on this machine points to the DNS server on the same machine. It just points to the loopback. So I'm going to go back to our network map. So the DNS client on this machine points to the DNS server on the same machine. If I go to DC2 and look at those client settings, and I look at the IP settings there, I can see that this machine the DNS is pointing to the IPv6 loopback. So on this machine, this DNS client is pointing back to this server. And if I had another computer on the network, the DNS client would point to both of these. Now let's look at the DNS server. The DNS server is the start of authority for Contoso.com. It's also the start of authority for the 172 address, 172.17 and the 172.16. It's the start of authority for those namespaces. So if any DNS client send in a name for www.contoso.com, I don't like this pen. It would send that request to either DC1 or DC2. This is the first time I'm using my tablet. Guys, what I'm basically doing is remote connect, connecting to my tablet, which I have a pen for, which is a Chromebook incidentally. Now, if a client sends in a request for www.google.com, it will send it to these two servers just like it did www.contoso.com. So right now, I'm going to go to this machine, which is a DNS client, to DC1 and DC2. So I'm connecting to myself, the IPv6 loopback. So if I resolved www.contoso.com, it can't find an answer. And it's not going to send that request to anyone else. So DC1 wasn't able to give me an answer, and it didn't talk to any other servers. The reason being is DC1 is the start of authority for contoso.com. So basically, if DC1 doesn't know, then no one else will, because DC1 is the start of authority. So I'm going to right click, add a new host record. www should resolve to 172.17.0.4. And I'm also going to create a pointer record at the same time. So I'm going to create a host record to resolve that name to that IP. And at the same time, I resolve that IP to that name. So I'm going to go back to my diagram. I'm going to go back to my command prompt. So if I hit the up arrow now, I'm able to resolve the name. So what about contoso.com? www.google.com. So when I send that request in to these two DNS servers, they don't know the answer. So what they do is they contact the forwarders. So I'm on my DNS server, I'm going to highlight my server name and go to forwarders. So if I don't know the name, I need to send it to one of these two servers. So basically, as DNS servers, if they don't know the name, they're going to send the request. Let me do another color. I'm trying to get rid of the keyboard. So the black or the gray will be DNS clients. So now, if this client right here send a request to these two servers for www.google.com, those servers are going to follow these forwarders. So if you contact either DC1 or DC2 about a name that it doesn't know, it's going to send it to these two servers. The reason why this is unresolvable is because we never created records in DNS. Do you remember how I said that this is completely automated? That if a client is joined to the domain, it will automatically create a record for itself? Well, these two machines, they're internal DNS clients. Even though they're external DNS servers, they're internal DNS clients, but they're not joined to the domain. Just like the web server isn't joined to the domain, so it wasn't able to create a host record or a pointer record for itself. So we have to manually do that. So for eDNS1, That's going to resolve to 172.17.0.2, and I'm going to create a pointer record at the same time. And for eDNS2, that's going to resolve to 172.17.0.3. Click OK. So I'm going to go back to my server, click on forwarders now. It's actually able to resolve the IP to a name because I put in IPs here, and it's the job of the reverse lookup zone to resolve those names to IPs. I need to hit refresh. So now that I have an entry here, it's able to resolve those IPs to those names. Because remember, my DNS client on this machine is pointed to the DNS server on this machine. So when I opened up this utility, it tried to resolve these names, these IPs to names. The DNS client contacted the server. The server didn't have any pointer records for these two IPs, so it wasn't able to resolve the names. So once I created a pointer record entry, it was able to resolve these IPs to those names. So basically, this client wants to resolve www.google.com, and it sends the request to these two machines. These two servers don't have an answer. So they're going to send, the client's only going to talk to one of them, but they're both going to behave differently. This machine, let's say the client talked to this machine only. It's going to send the request to either, I did those arrows wrong. So these servers will contact these servers for an answer. So let's go look at those servers. I'm going to go to eDNS1. So we're going to pretend that this client talked to DNS1. DNS1 didn't have an answer, so DNS1 is going to talk to eDNS1. I'm going to sign in. So eDNS1 is the start of authority for Contoso.com. So it doesn't know about Google. So if this doesn't know about a namespace, I'm going to highlight the server, look for the forwarders. This server is going to send to one of Google's DNS servers. So I'm going to go back to the diagram. So if this server doesn't know an answer, it's going to send it out. Guys, I'm going to assume these are DNS servers on the internet. So it's going to send the request to one of those servers on the internet. And this will do the same thing. So basically, this client will contact these two DNS servers. These two DNS servers won't know an answer. They'll send the request to this DNS server. It doesn't know the answer. So it's going to send it out to the internet. The reason why we have such a convoluted path is because we need to keep our DNS secure. These two DNS servers know about our internal IP scheme. These two servers only know about our external IP scheme. So we need to protect these DNS servers and keep them off the internet. The only two machines, as far as DNS servers, are actually going to communicate with DNS servers on the internet will be these two. because the reason is if these two get compromised, no big deal. They only know about our public IPs. But these two machines, we don't want to get compromised. So we don't want to allow them out on the internet. So every time they don't know an answer, they'll send it to these two servers. These two servers will go out to the internet. Let me clear all this. Just going to erase it all. Okay, let's look at eDNS1. Okay, eDNS1, the DNS client is going to point eDNS1 as a client to that machine or that machine for DNS. So if I want to resolve www.contoso.com, these two servers are going to be able to give me an answer and give me a private IP. So if this machine wants to connect to the web server, it will know the private IP and will connect directly. We don't want this machine to connect to the servers on the same box. So if let's just say I had it connect to the DNS server on the same box, and I did www.contoso.com. It's going to resolve it to an outside IP address. So if this server wanted to connect to this web server and I resolved it to this IP, the packet would come here to here, then this router wouldn't know what to do with it and saying, well, the IP you want to go to has been translated back down to here, and it would just confuse and die right here. Let me give you another example. If I connected to a school's DNS server, 10.13.2.5, and I resolved Broward.edu, it would give me that's a bad example because it's still a public IP. Let me think what other server I can use. Well, they might have moved the server out to the internet, but that's a bad example. So I don't want to. I don't want to do that. Um, Let me go back to the diagram. So if you're inside of our network, we want to resolve it to a private IP. We don't want to resolve it to a public IP. Because if you resolve it to a public IP, you would send that request to that server there. So as a DNS client, if I wanted to connect to the web server that's inside my private network, I would just type www.contoso.com and it will connect me to my internal website. No problem. That's the website that we set up. But if I pointed this machine to the DNS server on the same box, what would happen would be that it would try to go out to the internet to get to this server. So at that point, it would never be able to reach the server. Okay, so I'm going to go back to NSLookup. Okay, let's say I wanted to go to www.google.com. So I want to resolve that to an IP. So in a case like that, this DNS client points to this DNS server. So the green is the client communication. Now the red will be the server communication. Does DC1 or DC2 know about Google.com? No. So who does it go to? It goes to the forwarders. Who does it forward to? So now it's going to forward it back to one of these two boxes because it doesn't know the answer. These two machines don't know about Google.com, so they're going to forward them to two DNS servers on the internet, Google's DNS servers. So basically, as a client, if I want to resolve www.contoso.com, I'm going to send it up to these servers. These servers don't know the answer, so it's going to send it back down to the forwarders, which is the external DNS servers. These DNS servers don't know the answer, so it's going to send it out to the internet. I'll get the answer, send it back to this server. This server will cache it. Send it back to this server. This server will cache it. Then send it back to the client with the answer. Basically saying for that name, there's the IPv6 and the IPv4 address for that server. So it seems kind of convoluted, but after a while it'll make sense. If any of these machines are behind this NAT router right here, then at that point they need to point to an internal DNS server. Someone coming in from the internet, they'll use these two DNS servers. So let's go in and connect to the DNS server on the same machine. So we're going to pretend we're a client out on the internet. And then I'm going to connect to eDNS1. So when I connect to eDNS1, I'm going to resolve Contoso to 10.0.0.8. So if I had a client out on the internet, I'm going to assume that this machine and this machine are registered to host the name contoso.com on the internet. We contacted our ISP. We paid them to let us handle our namespace. So we bought the name contoso.com. When you buy a name, you have to handle the name resolution. So these are registered DNS servers on the internet. So if this machine wants to resolve www.contoso.com, they contacted some servers on the internet, and eventually they sent me to either this IP 10.0.0.6 or 10.0.0.7, which means it's going to send me to that interface for name resolution. That interface is going to see traffic for 0.6, send it to this machine. That machine is going to resolve the name www.contoso.com to 10.0.0.8. And at that point, I'm going to pause the video while I'm erasing all this. Okay, so we have a client out on the internet. It contacted this DNS server right here through this interface right here. And it resolved www.contoso.com. And it resolved it to 10.0.0.8. So at that point, this client is going to contact this NAT router. It's going to think that that NAT router is the web server. Well, that NAT router isn't the web server, but it will send that traffic in to the web server, and the web server will be able to respond. So that's how the external DNS servers work as far as host on the internet. One more topic. Okay, so I'm going to exit out of this. I'm going to go into DNS, and I want to look at this name. You notice how it puts a dot after here. It would be, what name was that? Let's just use google.com. There's an implied dot right here. You don't type it, but you can type, you can if you wanted to, but it would come up to the same thing. So this dot right here is called a root domain. I'm going to go back to a DNS server, doesn't really matter who. I'm going to highlight my server name, then click on root hints. So basically, there's only A through M. These are the root servers. What these servers do is they resolve to top level domains. And this is a top level domain. A top level domain would be .com, .gov. I thought this was going to have a more detailed list. Let me go back here. So a top level domain is the .coms, the .net, the .govs, the .info, the .ca, the .app, tech, .edus. Also, like if you're from Brazil, you would have a .com -br. That BR stands for Brazil. That's still a top level domain, even though it's to um, there's two dots in it, it's still considered a top level domain. So how it works is we have forwarders. If we don't know the answer, we contact a forwarder. These forwarders are most likely going to be our ISPs. And if the ISPs don't know the answer, they're going to contact a root server. So if you contact a root server, and the root server is going to give you back the IP of the COM server. Then the COM server is going to give you back the IP of the DNS servers for Google. Remember when I said we had to register these two servers on the internet? You need at least two servers. That's called a second level domain. Second level domain. So basically right here is the second level domain. So that is the name that you register. So when I register a name, google.com or contoso.com, I'm registering it on the .com servers. And all I'm doing is telling the .com servers who are the DNS servers for this second level domain. So if we had when we register our name, we would say for the Contoso second level domain, the two DNS servers are 10.0.0.6 and 10.0.0.7. So if our forwarders are down, meaning that's who we contact if we don't know the answer, we're going to use their root hints. So basically, we're going to contact the root server. The root server is going to give us the IP addresses of the COM server. The COM server will give us, and basically it's just going to be the DNS servers for COM. Then the COM server will give us the DNS servers for Contoso. Then we're going to contact Contoso DNS servers, and it's going to give me the IP address for www. And at that point, then the client can contact that server directly. So you contact the top level. No. You contact a root server. It gives you the DNS servers for the top level. The top level will give you the DNS servers for the second level. Once we get the IP of the DNS servers for the second level, we'll contact those DNS servers, and those servers will resolve www to an IP. We don't want to just not use forwarders. We could get away with erasing these and still it would automatically connect to a root server. But can you imagine if in the entire world, if everyone contacted these, I don't know how many servers there are, we would bring down the internet relatively quickly. If you can't resolve names, you won't be able to get to any websites. So it's not playing nice on the internet to talk directly to a root server. Also, if you do that, it's going to probably slow down name resolution. Because remember when we talked about this time to live? Basically, our DNS servers is telling you to keep it cached in memory for 1 hour. So if we contact our ISP's DNS server and they have a cache, they'll be able to give me the answer immediately. It's a very slow process having to contact this server sends me to this server sends me to this server, and this server gives me an answer. If you talk to those ISP servers, they might have it cached in memory, so you only have to talk to one server, and would actually speed up name resolution. Plus, it's offloading a lot of work from these root servers. These root servers can come down quite easy. So the only people who really should talk to the root servers are the ISPs. If you need an answer about a public namespace, contact your ISP. If they don't have it cached, they'll go through this process for you. They'll contact the root server. The root server will give them the IP for the COM server. They'll contact the COM server, contact Contoso DNS servers, then find out the answer. And from that point on, the root server will keep it cached in memory for 1 hour. So if someone else try to contact my ISP's DNS server and try to resolve www.google.com, it can pull from cache. It doesn't have to go through the whole entire process of talking to a root server, then a top level, then a second level, just to get an answer. Okay, last two topics. I have server-side cache and client-side cache. So if I highlight my server and click on advanced, I can see my cache lookup. These are all the names in memory that I saved. So there's my root server. There's that ARPA address for my reverse. Here's the COM servers that I've dealt with. So these are all the names that I've had cache. If you're in the middle of setting something up and you cache something improperly, you can highlight your server and clear the cache. And at that point, nothing will be in my memory. The only thing I know about at this point are the root servers. But I haven't talked to anyone yet, so I don't have an answer yet. So I'm going to go into a command prompt. I'm going to do ipconfig display DNS. And this is the DNS client-side cache, which is different than the server-side cache. Because when the client talked to the server and the server found out the answer for me, the server cached it, and when it sent it to the client also cached it. So if I try to contact this website again, that was probably some sort of network ad that I picked up or something. I don't need to contact the server. I'll just pull it from cache because whatever the time to live, I'll keep it in memory for that amount of time. So if I go to www.google.com and go back to www.google.com within an hour, I don't need to contact any DNS server. I just have it in my client-side cache. Again, if you mess something up and you need to clear your cache, you have to clear the server-side cache, and then you have to clear the client-side cache, which is I can't remember the command, believe it or not. Oh, there it is, flush DNS. This will clear my client-side cache. So now if I try to display the cache, it'll be empty. So keep in mind, guys, when you mess up and you're correcting something, you have to make sure that you clear the server-side cache and you clear the client-side cache. Guys, this is a very difficult topic to do in front of you. I can't imagine what it's going to be like to do it remotely. So some people can't come to the lesson tomorrow, but this is what I'm going to talk about tomorrow. So if you have questions, hopefully everyone watches this video before tomorrow. I don't know how well that's going to go. So I might move it off to Thursday to give more people time to watch the video. I just wasn't able to do it um, this last video over the weekend. So we'll see how it goes. Guys, this is going to be the last topic for DNS before we move on to DHCP. Hopefully you watch this before we have our live session, and then you're able to ask me questions from there. Okay, guys, that's it for DNS. The next topic we're going to cover is DHCP. Thank you.